Okay, so we talked about it really quickly at the end of the class on Monday, speeding up and slowing down. We said that speeding up means that both vectors for velocity and acceleration must point in the same direction, right? Velocity is going this way, going to the right, and if acceleration is going the same place, then it pushes it, and then it gets faster. If the velocity is pointing to the left, acceleration is also going to the left, then it pushes it, and then it goes faster. The direction doesn't matter, it's just whether they're both going in the same direction or not. If they're going the opposite direction, it must slow down, okay? So this is very important. So speeding up, I think you already wrote this last time. Speeding up basically means V and T have the same direction. And then slowing down means that they have opposite direction. Okay, so what we want to do, in order to figure out which intervals will actually speed up, which interval is going to slow down, you need some sign charts. One sign chart for V of t, one sign chart for A of t. So let's go ahead and take that same function we did. Let's just write down V of t. V of t was 3t squared minus 12t plus 9. And then A of t is 6t minus 12. So what we want to do is draw two sign charts. One for V of t, and then the other one for A of t. And then, what is this asking for? Okay. We're going to start at 0 because at the very beginning of the problem, it says t greater than or equal to 0. So only for that interval. So sign chart for V of t, let's see. We have 1 and 3, they're the zeros, and then we have plus, minus, plus. A of t, 6t minus 12. So that means A is changing direction at 2. Yeah, sorry, 2. So 2, and then we're going to go negative, positive. You guys are with me, right? Okay, then, so we're trying to see where they overlap. So what I would do is just kind of draw your lines. Basically, you have a few breaks, right? You have 0 to 1, 1 to 2, 2 to 3, 3 to infinity. You're looking for the ones that have the same signs for speeding up. The ones that have different signs are slowing down. Okay, so let's go ahead and just like categorize them. So let's say speeding up. And then we have slowing down. All right, so you can see that I broke this into 4 intervals, 0 to 1. So 0 to 1, is it speeding up or slowing down? Good. Why is it slowing down? They're the opposite, yes. So if the question says justify, why do you think it's slowing down? You would say because V of t is positive and A of t is negative. Or you can say they have different signs. Okay, so those are all good. Okay, so 0 to 1, and then we're actually going to not include 1. Because we're just talking about the positive and negative, not the zeros. All right, from 1 to 2. Oh, did I put it in the wrong place? Sorry. Okay, 1 to 2. Speeding up or slowing down? Speeding up. Even though both of them are negative, you're thinking, oh, slowing down. No. As long as they're both pointing in the same direction, it is speeding up. All right, 2 to 3. Slowing down. And then 3 to infinity. Yes. Are you guys good? Yeah. Okay. All right, one last question, and I'm going to let you start the activity. Yeah?
So when the acceleration is constant, is it just never speeding up or never slowing down?
Constant, that's a great question. Constant as in there's a number?
Yeah.
Okay, if the number is positive, it's still positive, right? If A of t is 2, that's a positive number. Unless you're talking about A of t is 0, then it's not accelerating. It's basically constant speed. Yes?
So when it says the acceleration is equal to 0, when is the acceleration equal to 0?
Mm-hmm.
But a of t is just like
A number.
6.
Uh,
Acceleration never equals to 0.
yeah, acceleration never equals 0.
So, wait, sorry.
Yeah.
Okay, so if the acceleration is like 2, so it's positive, so with the velocity, whenever that one's positive, then it's speeding up, and then if it's
Yes.
negative, it's slowing down.
Yes. Okay, next. Sorry, yes.
So we cannot solely depend on the acceleration
No.
line chart to see if it's speeding up.
Correct. You have to check both. Yeah. Okay, last one. This is also a very typical problem. It's a very physics problem. You throw a ball upward with an initial velocity of 80 feet per second. Its height after t seconds is s of t equals 80t minus 16t squared. What is the maximum height reached by the ball? Okay, so you throw something up. What's going to happen to the ball? It's going to come down. After what? Maximum height. Once it reaches maximum height, it's going to come down. What happens at maximum height? Velocity is 0 because it kind of stays there and then comes down, right? For a moment. So the maximum height means that is when v of t is 0. So the question is when, oh no, it's not asking for when, is what is the maximum height? So what is the maximum height means when is the maximum height. So we had to first figure out when and then what. So, okay, so the question is when is the maximum height going to happen? And then we can figure out the actual height. But either way, we know maximum height happens when v is 0. So that means we need to find the derivative of s. I'm sorry. No, t. Okay, so that's equal to 0. Solve 80 is equal to 32t, so divide by 32. T is 80 over 32. Let's just simplify that. So divide by 8. No, can we? 16? 16. 16, 4. No, 5. What am I doing? 5 and 4.
5 and 2.
5 and 2, sorry. 5 and 2. 2.5, yes. Okay, so this is the time that the maximum height happens. Now, how do I actually find the height? Plug into first equation. Okay, so plug it back into S. 80 times 5 over 2 minus 16 times 5 over 2 squared. So that's 200 minus 16 over 25 over 4. What? 100. Let's make sure we have units. This is S, this is feet. Yes. That is a great question. For this one, that's a great question. Let's do one. I think for these kind of questions, you don't need to because you have this equation that tells you it's a parabola. So parabola and it's downward, we know it has to go like that. But we can just do a sign chart just to double check. So this is 80 minus 32. That is, no, this graph going down. So plus minus. Yes?
Do you still cap it off at 0? Because technically you can't do like negative seconds.
Oh, that is a good question. Yes. Yeah, so no negative seconds. All right, now next question. What is the velocity of the ball when it is 96 feet above the ground, on its way up and on its way down? So when you throw at the beginning, you're going to say that is 0, right? This is where you throw, and you throw it up. It's going to reach 96, and then it's going to reach 96 again. On the way up, on the way down. So the question is, how fast is it at 96?
Can we just plug it into the V2?
Yes, but when is 96 feet going to happen? You had to find that out, right? So when are you going to reach 96 is the question.
96 equals
Yes, so 96 has to equal S. So 96 is equal to 80t minus 16t squared. We're saying that this height somewhere in time is equal to 96. When is that going to happen? At two places. On the way up and on the way down. Okay, so let's go ahead and solve this. I'm going to move everything to the positive t squared. So 16t squared plus, minus 80t plus 96 equals 0. I think they're all divisible by 16.
Yeah, I believe so. Yes.
Yes. T squared minus 5t plus 6. This is very nice. T minus 2, t minus 3. 2 and 3. So as 2 seconds and 3 seconds. Which one do you think is on the way up?
2.
Yes, it happens first, right? Okay, so the question is, what is the velocity at 2, and then what is the velocity at 3? So go ahead and do that. Remember, the question is velocity, not speed. Velocity, not speed. So that means they want a direction on this.
So how do, because I know what the sign is, but how do they factor that into the equation?
You don't have to care about the sign. If you plug it in, the sign will come out correctly. All right, so a lot of you are doing this in your head and getting the answer, I'm gonna guess. V of 2 is what? 16, what's the unit? Yeah, feet per second. What about V of 3? Negative 16. Good. So make sure you put a negative there. That tells people that you're actually it's gonna go down. Okay? That's it.